Hello, space explorers. Welcome back to the channel. Today, we're diving headfirst into one of the most mind-boggling, awe-inspiring, and frankly gigantic structures ever discovered in our universe. Forget your galaxies. Forget your superclusters. We're talking about something so immense, it challenges our very understanding of the cosmos. Get ready, because we're about to explore the Hercules Corona Borealis Great Wall, a structure so vast, it makes the phrase unfathomably large feel like an understatement. By the end of this video, you'll have a whole new appreciation for just how truly enormous our universe can be. So, what exactly is the Hercules Corona Borealis Great Wall? Or HERCRBGW for short? Because that's a mouthful? Imagine the universe as a giant sponge. You've got the sponge Y bits, those are the filaments and clusters of galaxies. And then you've got the holes, the vast cosmic voids where there's almost nothing. The HERCRBGW is one of the most prominent, densest, sponge Y bits we've ever found. In astronomical terms, it's a large quasar group, or LQG. Now, a quasar is basically the incredibly bright, active core of a very distant galaxy, powered by a supermassive black hole gobbling up matter. They're like cosmic lighthouses, shining across billions of light years. An LQG is simply a massive collection of these quasars, bound together by gravity, forming a gigantic structure. The HERCRBGW was first identified in November 2013 by a team of astronomers led by Istvan Horvath, John Hakila, and Zsolt Bagoli from Hungary and the United States. They weren't just looking for big things, they were specifically looking at the distribution of gamma-ray bursts, or GRBs. GRBs are the most powerful explosions in the universe, believed to be the birth cries of black holes or the merger of neutron stars. And here's the kicker. These GRBs weren't randomly distributed across the sky. They appeared to cluster together, pointing towards something immense. And when I say immense, I mean immense. Get this, the estimated size of the Hercules Corona Borealis Great Wall is about 10 billion light-years across. Let's put that into perspective. Our own Milky Way galaxy is about 100,000 light-years across. The local group, our cluster of galaxies, is about 10 million light-years across. The Laniakea supercluster, our galactic neighborhood, is about 520 million light-years across. The HERCRBGW is roughly 1/10 the size of the entire observable universe. It's located approximately 10 billion light-years away from us, in the constellations of Hercules and Corona Borealis, hence the name. At that distance, we're looking back in time to when the universe was only about 3.8 billion years old. So, this monster structure formed remarkably early in cosmic history. Now, this is where things get really interesting and potentially problematic for our current understanding of the universe. Central to modern cosmology is something called the Cosmological Principle. In simple terms, it states that on sufficiently large scales, the universe is homogeneous and isotropic. Homogeneous means it looks pretty much the same everywhere, no matter where you are. Isotropic means it looks the same in every direction. Think of it like this. If you take a large enough chunk of the universe, it should contain roughly the same amount of matter, distributed in roughly the same way as any other equally large chunk. There shouldn't be massive, inexplicable clumps or voids beyond a certain scale. The sufficiently large scale, where this principle kicks in, is generally thought to be around 1.2 billion light-years. Any structure larger than that would, theoretically, violate the cosmological principle. But the Hercules Corona Borealis Great Wall, at 10 billion light-years across, absolutely shatters that limit. It's nearly 8 times larger than what the cosmological principle would comfortably allow. This is a huge puzzle. So, how did such an impossibly large structure form so early in the universe's history? This is where cosmologists scratch their heads. According to our standard model of cosmology, structures grow over time through gravitational attraction. Smaller clumps of matter merge to form larger ones. But forming something 10 billion light-years across in only a few billion years just doesn't seem to compute. It would require far too much time for gravity to pull all that matter together. This leads to a few possibilities, each with its own set of implications. Possibility 1. The cosmological principle is wrong on these scales. Perhaps our understanding of the universe's homogeneity is flawed. Maybe the universe isn't perfectly uniform on these extreme scales, and such massive structures are indeed possible, forcing us to revise our fundamental models. Possibility 2. We're missing something in our models. Could there be an unknown force or mechanism at play in the early universe that allowed for the rapid formation of such immense structures? Maybe some exotic form of dark energy or dark matter interaction that we haven't accounted for. Possibility 3. It's an anomaly/statistical fluke. While less likely given its size, it's always possible that what we're seeing is a highly improbable, but not impossible statistical anomaly. But for something this big, the odds are incredibly small. Possibility 4. Observer bias or interpretation issues. Is it possible that our method of identifying these structures, particularly through GRBs, might be introducing a bias? Could the apparent wall be an alignment of unrelated objects from our perspective, rather than a truly bound structure? However, the statistical significance of the discovery suggests it's not just a random alignment. The Hercules isn't the only cosmic behemoth challenging our assumptions. It's part of a growing list of too big structures that are pushing the boundaries of cosmology. The Sloan Great Wall. Discovered earlier in 2003, the Sloan Great Wall is another vast cosmic filament, about 1.37 billion light-years long. Still massive, but considerably smaller than the Hercules. The Giant Arc. More recently, in 2021, astronomers discovered the Giant Arc, a curved string of galaxies and galaxy clusters spanning 3.3 billion light-years, located 9.2 billion light-years away. This one also challenges the cosmological principle. The Claus-Campusano LQG. This LQG, discovered in 1991, was the largest known structure at the time, spanning about 2 billion light-years, also prompting questions about the cosmological principle. The consistent discovery of these impossible structures suggests that something fundamental might be missing from our understanding of large-scale structure formation. Or perhaps the universe is simply more lumpy than we thought on these truly enormous scales. So, where do we go from here? The Hercules Corona Borealis Great Wall remains a fascinating and perplexing enigma. Scientists are actively working to understand it better. Future research will involve more observations, looking for more quasar groups, more GRB clusters, and other tracers of large-scale structure to see if these patterns are consistent or if the Hercules is truly unique. Improved simulations. Running more sophisticated computer simulations of the early universe to see if any tweaked parameters or new physics can account for the formation of such massive objects. Theoretical advancements. developing new theoretical frameworks that might explain how gravity or other forces could allow for structures of this scale to form within the known age of the universe. New cosmic microwave background data. Further analysis of the cosmic microwave background radiation, the afterglow of the Big Bang, could reveal subtle anisotropies or patterns that might hint at very early, large-scale structures. The Hercules is a testament to how much we still have to learn about our universe. It's a reminder that even our most robust scientific theories can be challenged by new discoveries. The Hercules Corona Borealis Great Wall stands as a monumental challenge to our understanding of cosmic evolution. It's a structure so vast, it forces us to reconsider the very fabric of space and time on the largest scales. It's discoveries like these that make cosmology so exciting, constantly pushing the boundaries of what we thought was possible. The universe never ceases to amaze and humble us. What are your thoughts on the Hercules Corona Borealis Great Wall? Do you think it breaks the cosmological principle? Or is there another explanation? Let me know in the comments below. If you enjoyed this cosmic journey, be sure to hit that like button, subscribe for more space adventures, and ring that notification bell so you don't miss our next video.